Aggies know the state of parking at Texas A&M, constantly cruising around looking for lots that don't require $100 permits while adding to the congestion of main streets. We sent out a voluntary survey to students of Texas A&M with 117 respondents. Students responded not being able to get a spot near their classes, traffic is brutal, and getting parking is so difficult. Transportation clearly dominated the survey as one of the biggest issues facing students on campus, and we hope to be an answer. In a paper from the University of Melbourne, they discovered that drivers on average spend 7.8 minutes cruising for a parking spot, and the act of cruising alone adds 30% to traffic. Traditional methods of parking monitoring can be very expensive, as numerous amounts of hardware would have to be installed all over campus. Instead, we've identified pre-existing infrastructure that we can utilize to provide exact locations of vacant parking spots. Using surveillance structures already implemented, such as security and traffic cameras, detection of vacant spots can be done using machine learning to recognize the absence or presence of vehicles in the form of an application for ease of access to drivers. Our solution also respects the privacy of the drivers, as we don't let users directly access surveillance footage. Now, let's take a look at the application. After you sign into the app, you can see some parking lots next to you, as well as your capacity. I'm looking for a parking spot next to my apartment, so I'll click on this parking lot. As you can see, the video on the left is the footage from the surveillance camera. As cars move in and out of the parking lot, the UI in the app updates in real time to reflect that change. Finding a parking spot is as easy as taking a glance at my phone. Now, let me explain how our application works. First, we need to define the parking spaces. We assigned an ID to each parking space. Then, we recorded the X and Y coordinates of the 4 vertices of the polygon that encloses each space. Although tedious, this is the only manual step in this process, and it only needs to be done once. To imitate the surveillance camera, we shot a video from our handheld camera, which we then stabilized in Photoshop. As the video is being transferred into the computer, we have a Python script that captures 1 frame of the video every second. These frames are then sent to our Python server. The server passes these frames through YOLO, a popular real-time object detection convolutional neural network. The network is able to find all cars in the image and draw a box around every car. We then compare the overlap between the box and each parking spot to determine whether a parking spot is taken. Using socket.io, we send the results of these computations in real time to our React Native app, which displays these results on a user-friendly interface. And there you have it. Using the magic of machine learning and pre-existing infrastructure, our app can help to alleviate the parking problem at the A&M campus. As long as the parking lot managers are willing to plot out the parking spots, they can drastically modernize their parking space. In the future, we hope to train our own convolutional neural networks to identify parking lines and plot out the parking spots automatically, making this process even easier.